Now, people are familiar with Windows and Mac OS, but there's a third operating system that many people don't know much about, and that's Linux, and that's probably on more devices than Windows and Mac OS combined. In this video, we'll be talking about what Linux is, what distributions are, which ones are out there, and the ones that you'll probably be most likely to encounter. We'll also be going over some basic commands and how to navigate around a Linux file system. Now, most people are wondering what is Linux and how did it get its name, and what does that have to do with Unix? Well, Linux was developed by Linus Torvalds from 1983 to 1991 as a free and community-driven open source alternative to the Unix operating system. Now, Unix was first developed in 1969 by AT&T Bell Labs. Originally, it was just meant to be an operating system for internal use, but they realized they had a gold mine on their hands, and it basically became the world's first portable operating system that would eventually run on many different platforms. Up until this point, operating systems tended to have to be to a very specific model of computer. Unix sort of started that way, and then it just expanded through the 70s. It was eventually licensed to commercial product all through the 1970s. It also spawned a wave of Unix variants such as BSD, which was created by UC Berkeley, Xenix, which was created by Microsoft, Sun OS or Solaris by Sun Microsystems, HPUX by Hewlett Packard, AIX for IBM. You might be vaguely familiar with some of these. Um, However, the problem was the cost was expensive. If you're going to license to a company, it could be $10,000 to $20,000. This was an ongoing licensing fee, I believe. Academic, it could be a little cheaper, as low as 1 or 2 thousand, which is definitely something a computer science department could probably afford, at least if you're a bigger college. But it could be compounded by the fact that you had to pay more for even more. You wanted to look at the source code, you had to pay. Other programs, you had to pay. Keep in mind that Unix isn't necessarily a strict definition of an operating system. It's more of an idea, a standard really, than a strict one. So that the other ones that I mentioned, like BSD, is basically part of the Unix-like superfamily. And that's why we use the term Unix-like when that can describe a lot of operating systems. Linux, even Mac OS started life with a Linux kernel, which by extension iOS and Android even runs a Linux kernel as well. Now this continues the question, what is Linux? We define it as an operating system, but the strict definition is that it just refers to the kernel. We call that Linux. Or we even call it GNU Linux, but we'll explain that in a bit. So various distributions are built up from this kernel. Now, a kernel is just the core system of any operating system. It basically sits between hardware and software. It's always present in memory. It's never unloaded. It's essentially the government and the traffic control of the operating system, and it decides how the operating system is run. Now, a distribution packages a Linux kernel with software, usually general public license stuff that gives you full rights to publish and modify the software as long as the license stays intact. Now, the very earliest form of Linux, when it was still a little bit experimental, it did have less distribution. They just gave you the kernel, you figure out what source other software to develop or to use, and then users install it. But within a few months, you started to see early distributions. MCC Interim Linux was around for about a year. I believe it was the first thing to actually try as a distribution. And then there was Soft Landing Linux System, which I think that was just briefly around as well. Although from SLS, Slackware was developed. That was one of the first early widespread distributions, and it is still active to this day. If you actually want to use it, there's a lot of argument that it actually provides the most Unix-like experience of any Linux distribution. But since then, there have been literally over 1,000 different distributions since 1991, and at least a couple of hundred of them are being actively maintained. Linux can basically be made as simple or as complex as you need. It can be extremely tiny for niche applications. Your cable box is probably running Linux, and it's probably been running Linux for the better part of 20 years, maybe more. Or you can make it as big as any modern Windows or Mac OS installation. Now, what kind of Linux distribution is out there? We'll talk about families. Now, some of these will be argued to whether or not there are families, whether or not families actually exist. Again, one of the big ones, Debian Linux, that's been out since 1993. It's just still, I think, about the same time as Slackware, but it includes a lot of distributions within it, and then distributions. There's a whole hierarchical system that starts with Debian. So you've got Ubuntu that came out of 2004. The idea behind that is to make it very user friendly. If you don't use any other Linux, it's your first Linux. Ubuntu usually works. You throw it on a computer, it's probably going to work, and it's probably going to be easy enough to use. And then Linux Mint came out of that a few years later. Kali Linux, that's the Linux that tends to be on a lot of routers and stuff. It's kind of what you want to run if you want to feel like a cool hacker. And I guarantee you, people will either hate that I just said that, or they'll just totally own it when they put on their big leather trench coat and sunglasses. And then Raspberry Pi OS that came out in 2012. That's optimized for Raspberry Pis. You've got Red Hat that came out in 2000. That was probably the second, third version of Linux I used. Um, and then it spun off into Fedora as an open source version of Red Hat. CentOS, which I don't think it's been updated in a while. I've written down 2011, but I'm not entirely sure. Rocky Linux, that's fairly new. Alma Linux is also, and then there's the Red Hat, is it enterprise licensing or whatever. Basically, Red Hat is a company and they make commercial Linux and they make it very well. But there is Fedora that is open source. Arch Linux, which again, if somebody uses Arch, they're going to tell you. Um, Manjaro, they've also come out with Endeavor Steam. The Steam OS is a form of Arch. SUSE that came out in 2005. I know I've used that at least a little bit, um, but it's been a long time. There's other families, but some distributions, whether or not you call it a family, isn't very clear. Most people would say that at least two distributions you would have to make a family, and they'd have to be closely related, like one based on the other. You could technically go out tomorrow and start your own distribution of Linux, but you'd have to make it worthy enough for people to actually want to try it. Slackware, as I said, is the oldest, I think, that is still actively maintained, but some people don't even consider it its own family. Same goes for other distributions like Gentoo, Alpine. I mean, Android technically is sort of a Linux distribution. It uses the kernel at least, NixOS, and there's lots and lots of others. So the one thing we really have to discuss when talking about Linux is licensing and licensing types. Now, Linux was developed with the general public license. This allows users to publish, distribute, modify the software as long as the license is part of that software. It stays open source. It encourages community development. This is what much of Linux is licensed under. So this is why you can get many, many free versions of Linux. The free versions, I would say, far outnumber the commercial ones. Um, so most packages, applications, everything you're going to get free, free, and free. You're not going to have to pay hundreds or thousands of dollars for all of this. There is a bit of a downside. As long as it stays open source, open to the community, um, keep in mind there's some variations on this, like LGPL, AGPL. Um, there's permissive open licenses like MIT license, Apache license, BSD license. You'll see those things mentioned. It does allow for copywriting and modification with the modified software allowed to be commercial and proprietary as long as the original software it's based on still adheres to the original license. Um, so like Mac OS is actually a derivative of BSD under this kind of license. So the Linux kernel itself, nobody can take that and in itself, but the software surrounds it, they could. So you could make open license software on it, and a lot of it does. Then there's commercial proprietary stuff. This is where the source code is completely closed. License fees can be charged. Modification distribute rights can be limited. But on the upside, this usually means it's a major company that's going to provide updates, professional level support, training, all sorts of things, versus being dependent on the volunteer community, which is very great, but it has its limits. And then you kind of got dual licensing, where certain variants of the software can be created for different licensing types. You'll actually see this a lot. You'll see a lot of mixed licensing, where different aspects of the distribution are under their own licensing agreement. Every program, everything, it could be under different license. I mean, again, a lot of it's going to be GNU, MIT license, etc., though, as opposed to commercial or proprietary. But like with Android, the all the Google stuff is proprietary, even though you can otherwise just download and use Android. Now, as I said, there's a certain reality to the licensing. The core, classic software, some version of GNU, entire distributions have literally been made on desired licensing. So, like, you want GNU, you want MIT, BSD, dual mixed, whatever. As I mentioned, Android, it has GPL for the Linux kernel. It has BSD and MIT for much of the software, and then you have certain proprietary things that comes from Google, Google Store, Google Play, etc. Um, the MIT and the BSD license do allow you to take the software, modify it, and then even sell that modified version as a commercial product. This is how Mac OS and Android essentially were created. Um, MIT tends to be for Linux. BSD tends to be, you guessed it, BSD. Um, Free BSD distributions, even so. Um, the thing with BSD is it has one little quirk where it basically disallows you from using the original authors to promote your derived products or services. I guess at some point this was actually a major issue. MIT license just has to continue to have the MIT license, and notice same goes for BSD. Now, if you're talking about single board computers, most of them are ARM processors, usually ARM64, sometimes called ARC64. I think the second name is more generic. Like Raspberry Pis, they'll be probably running Linux. Um, there's ARM variants of Debian. They're very, very popular, and they're often the default OS. The new Arduino Uno Q, a lot of hybrid SBCs such as the Pi. And for the Pi, there's even Raspberry Pi OS to take advantage of the Pi specific features. Ubuntu is another popular choice. It's really nice for beginners because everything just kind of generally works. Um, and some people want to keep using that when they get to SBCs. You can use that with the Pi and everything. Although I recommend the Pi OS. You got Archarm, you got Manjaro. Yeah, there's a lot of popular options. I mean, as long as the distribution has an ARM version, you can probably put it on a single board computer. And keep in mind, not literally every single board computer is just ARM. There are ones that do an x86. Um, Chrome OS that's used on Chromebooks, well, that's based on the Chromium OS, which is free, which is based on Gen 2 Linux. You can put that on as well. Now, how do you install Linux? Well, if you're running a desktop or a floppy, you can install it a couple of different ways. Old floppy drives, if you're really old, CDs, DVDs, if you're kind of old, USB drives, other flash memory, that's a popular option. And drives are pretty big. They can fit an entire basic installation on there. You might use SD cards, like using micro SD cards with the Pi. You do network installations, or there's quite a bit different ways. If you're using MMC or SD for a single board computer, the Arduino Uno Q has a permanently soldered on ECE MMC that it's probably already installed. If you get a micro SD card for a Pi with a Pi, it's probably already installed there. It's pretty easy to get a SD card that already has it on it. I would say go with the official one. Um, Otherwise, you can just download it to your computer, and if, as long as you have some kind of ST adapter, USB thumb drive, or whatever, you can flash or just image it to it, and then you're off to the races, as it were. But if you're putting on a desktop or a laptop, great thing about Linux is, say you have a spare computer from a few years ago, maybe you have a laptop in a closet that still works. Yeah, you could use that as a perfectly good platform for Linux. um, Little Linux, I mean, it really depends. Desktop, if you're using the desktop GUI, but you can probably find Linux that can run on a potato clock. I'll be honest with that. Um, you do some setup, you put it in, you go through the various setup screens, the modern ones with desktop GUI, kind of similar to how you first set up Windows, I guess. Um, so you just put some basic details and you get it, as long as you can get it connected to the internet and have your user account created, it'll do much of the work. Keep in mind, single board computers and extra especially the Arduino Uno Q. They don't have a lot of resources of a downloader laptop, so downloading and installing those updates may take a little bit of time. Most of the more beginner-friendly distributions, they will just do this after the initial setup. Keep in mind, Linux software is updated very, very frequently. So you might install it, update it today, and then tomorrow there's more updates. Keep in mind, you don't have to feel, um, if you're not inclined to immediately update, that's probably not a big issue. As long as it works, it works. So with Linux, you kind of have two ways you can use it. The classic way is command line, command prompt without a graphical user interface. That was really common through the 1980s and even into the 1990s. If you used MS-DOS, PC-DOS, whatever, you had a text prompt. There were some things that provided you a little bit of graphical user interface, file managers, but Windows 1 and 2, I mean, I didn't even hear of their existence till Windows 3 came out, to be honest. There were things like Norton Commander, but for the most part, you were just at a text prompt. And this started to change with the first Mac. I think that was 84. Amiga maybe was a few more years. And then Windows 3 came out and everything changed. Um, I want to say by 93, maybe 94, it really was the default operating system for PC and PC compatibles. Um, you still have command prompt and PowerShell as part of Windows. That's a text-based experience right there if you use them. Most modern day PC users have little or no experience with command line stuff, and you really don't need to. But if you already have at least a basic understanding, you've used at least some command prompt and PowerShell, then that'll actually help with learning Linux. So Linux can basically be booted into either the classic command line or one of the desktop GUI options that are out there. It really depends your operating system to what the default one is, but most of them are kind of similar enough. But you can still pull up command line with a terminal emulator. So when we talk about Linux and desktop GUI, the earliest GUI is basically X Windows. The most modern version is X11, but there was X10. It might have been before that, and I think it got ported to Linux pretty early there. It wasn't a full interface, but it did provide some graphical windows, mouse input support, basic rendering, and it was pretty much available for just about everything across the entire Unix-like spectrum. If there's alternatives from that time, I'm not familiar. But in this case, it's multiple program services protocols when they're just kind of linked together with a service and a client connecting to it. With X Windows, everything's a client, like an application as a client and session as a client, etc. They started adding window managers. I want to say early 90s too as well. This added some more GUI interaction, movable windows, things to make it look closer to Windows. Um, Now, KE, that's K Desktop Environment, that came out about 98. I think they stopped work on that in 2014, was basically the first full-fledged desktop GUI that kind of had everything together. was eventually split into different packages in 2014, and it still exists. Then we had GNOME, that started out about the same time. So when I first really got into Linux, those were the options, but I didn't even have immediate. I don't even remember when I first saw the desktop GUI for Linux. We've had GNOME, and then the most recent version is GNOME 4, and that came out in 2021. That's been kind of the default GUI for Debian for a while, but you'll typically see it more on x86 systems. You've got like XFCE that came out in 97, that's meant for lower end, older systems. You'll frequently see that with single board computers. There's some other stuff when you're running desktop GUI stuff on a single board computer, you have to keep in mind the limited resources, and that's going to affect your GUI choices. Now, X Windows is no longer the only game in town. X11 came out maybe 87, X10 about 5 years earlier than that. Again, it has a server that manages everything. Everything it connects to it is known as a client. um, as well as a window manager and all this, both window management and compositing handled separately. Now, Wayland came along, it could have been as long as 20 years ago, I don't remember, but it took time for it to sort of find a certain amount of acceptance. The big thing is it made things simpler and it built everything around then modern day hardware. So window management and compositing, it became simpler. It's all a compositor. Applications handle their own rendering. They can completely bypass the window management part, goes straight to the compositor. That saves a lot of time, better response. Um, but it may require more programs to work with older stuff. Older systems may not support it. If you're buying a Raspberry Pi, uh, 4 or 5 definitely, with Wayland 3 maybe even. But yeah, the older it is, it might not be as supported as well. X Windows, it's very time tested. It's been around for like 40 years for X11, older if you're counting like X10. It'll work on pretty much anything in the entire Unix like superfamily. Both systems do need specific managers applications if you want to get them to work efficiently, faster on ARM systems, especially hobby single board computers like the Pi. Now, models 1 and 2, they used X11, used OpenBox, and LXDE. The OpenBox is the window management, I believe, and LXDE would be the environment, the graphical environment. 3, X11, OpenBox, and they were still using LXDE, but they sort of started to transition to Pixel. I believe my 3B Plus is running Pixel. 4, that's where they started to really make the transition to Wayland, and you either had OpenBox for X11 or you used Wayfire as the compositor for Wayland and Pixel. 5 just uses Wayland by default, and thus it uses originally used Wayfire as a compositor. More recently, it's now LabWC, and it's still using Pixel. A Wayland also is going to run X Wayland that provides compatibility for Wayland, so it can use all those X11 applications. So you'll commonly see that running. A full Wayland system with good resources, almost the same response times as Windows or Mac OS. The difference is there, when you're dealing with like a Pi, certainly with a Pi. But yeah, that distance is closing quickly. Now, I'm not sure about everything else, but the Uno Q that's a hybrid, so it's a lower end single board computer. It runs Debian, it runs XFCE with light DM because of the very limited resources of the Q. The NVIDIA Jetson Orin Nano, it runs its own version of Linux, which is based in Ubuntu, I think. It uses GNOME Desktop with some heavy modifications. Orange Pi 4 Pro apparently runs its own version of OS and it's Arch base instead of Debian based, called Orange Pi OS. I have no experience with that. Uses XFCE. The Radic Rock 5 apparently runs its own OS. In this case, it's Debian, and then it uses KDE Plasma by default. I would say any single board computer setup, I would definitely research it, what it does. Um, depending on your application, there are a lot better and maybe even cheaper things than the Pi. But the Pi is just so much out there in terms of resources, tutorials, etc., that everybody in single board community probably will know what you're talking about. All right, so how do you use it? Well, you first put it into Linux. You'll probably get a desktop GUI login, probably a setup. At that point, if you got the GUI login, you're probably going to the desktop environment, or you get a command prompt asking for username and password. Um, Again, if you haven't already seen it, you'll probably see an interface that lets you set up your initial account. That's increasingly common with distributions. Um, but if you get really crazy with what you bring in, it may not be that simple. Um, but if you look in the documentation for installation, there's already an account. Maybe it'll already tell you a username, password. The good thing is anything you can run into, there is tons of documentation. In some cases, going back years, maybe even decades. There's nothing that is undocumented for the most part when it comes to Linux. At least with desktop environments and distributions, you might find some relatively obscure game or program. But other than that, if it's command line, it's probably going to start you off in your home directory. For your user account, it's going to have bash set up. That's a shell environment. Um, in this case, you'll not only be learning the operating system, you'll be learning the default shell environment at the same time. If you are completely unfamiliar with how to use a command line, this is going to be a much steeper learning curve than those of us that are old enough to be experienced with DOS or Linux in general. But command prompt PowerShell, that's probably where you'll see the closest similarities. All right, so let's start with a little basic directory navigation. Now, CD, and this works in a lot of the other DOS operating systems, it just means current directory. You click CD, well, you're in your current directory. Um, you add a dot, two dots, that'll back you up one level. You can do CD and then a directory name, move up inside the directory, CD tilde, that returns you to your home directory. Keep in mind, home directories a variable that can be set and unset. PWD, that's just print working directory. That just tells you what directory you are in. It is easy to get lost. Although if you're just starting out and you're just logging in, you'll probably be in /home/ whatever your username is. That assumes it's set up like that. That is a default in a lot of distributions, but it's not a guarantee. Now, if you actually want to see the files, you go with ls, which is short for list, and it'll just list the contents for the current directory, including other directories. If you give it -l, that'll give you more details. It displays them in a column. -a, that shows all files, directory shortcuts, anything that's hidden. You can combine the two. I frequently do mk direct. That's just make directory. It just makes a new directory in the directory you're currently in. You can use all those slashes and dots though to be specific where you want to make that directory. RM directory just removes it. Be careful with that. Um, in some cases, it will delete the directory and its contents. In other cases, if there's contents in the directory, it won't remove it. RM stands for remove. You can use it to remove files or directories. You run into the same issue with RM direct. Um, there's no easy to access trash or recycle bin per se with Linux. Um, Even in the desktop GUI, I'm not entirely sure. So be careful. If you want to remove everything in a directory, rm-rf, and then the directory, that removes the directory, everything inside. That is a dangerous command, so use it carefully. CP, that's copy, just copy one file to another. Again, you can use uh, all the directory structure you want with that. You can, yeah, just specify as is. Now, I've already explained how directory structure works. You've got the root directory, the top directory, and that's just a /home/username. Probably keep in mind system to system, distribution to distribution. Things may be set up if some guy's giving you an account on a system that's not yours, just kind of familiarize yourself with how things might be different. Again, it's also possible the system won't drop you in your home directory. You can always apply a path. So, dot slash would be, test directories inside the current one. If you want it to be inside the directory that your current directory is in, you also may have limited read-write access rights depending on file and directory. By default, you have full rights within your home directory, no guarantee for anything else. All right, here's a few more helpful commands. Man, that stands for manual. You can bring up a help file for just about every command. Keep in mind some of those pages are very short and straightforward. Other ones are exceedingly complex. You're basically reading a book, and it might just be easier to Google it. Cat, that stands for concatenate. That can be used a couple of different ways. The most basic is just cat and then the file name. It lists the file. Um, you can also, the line is called a pipe, and we're basically sending cat text file to less, and that'll let us scroll through it. It'll pause after the first page. You can just advance it. That's another neat thing with Linux. There's all sorts of symbols to do all sorts of things with your commands. MV, that just stands for move a file or directory. It's basically cut and paste instead of copy and paste. Clear, that just clears the terminal window normally, but it doesn't do anything else. Who am I? That just tells you the username of the account you're logged on. That can be useful if you're hopping between accounts. Nano and Pico, they're pretty popular simple text editors. Pico is older. It originally actually started as a simple email editor. That's when I started learning it. Nano is basically a newer version of it with a lot more features. Just use Nano. There's also things like VI and Emacs and other things. Don't worry about those. That's advanced users. They were built to emulate older systems, and don't get involved in people who are big fans of either. Just avoid their flame wars. I'm pretty sure there's been criminal things done when it comes to the VI versus Emacs argument. All right, let's look back on our system here and see what we can do. Um, I don't know, man, ls. All right, gives us a big page, all the flags we can do. Almost all. I mean, the list goes on. Readable. That H is going to give you better sizes. You can do, yeah, you can do basically all sorts of stuff. Just this command alone is a couple of pages. All right. Let's do cat. Let's do it on minute info and see what we get. Okay. Well, this was, I guess I did mim info from something for some reason. Well, let's pipeline that. Let's do with less. All right. Now everything fit on the screen, but if it didn't, and then to get out of this, we just hit Q. We could also do, I don't know, tail. It's going to give us the last, what, 10 lines. Head, that's going to give us the first 10. So yeah, you can get creative with these things, certainly. Now let's move things around. Well, let's move info to, I don't know, move info to. See, there you go. It didn't copy it. We've also got the editors. There's Pico. Let's call it, say, test one. We could specify it right here. All right, test one, blah, 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 blah. Quick box, jump with a lazy dog. All right. Um, Now everything down here is a control code, so control key plus whatever else you have. So control O, write down, you can put whatever name. I'm going with the test one because that's how I started it. There you go. Exit out. You got your file, test one, concatenate. There we go. And then we can, let's bring that up in, that was Pico. We opened it, right? Yeah, Pico. Yeah, it looks pretty much the same. There's some features under the hood. I believe I couldn't tell you off the top of my head. I know Nano's been a little bit more optimized over Pico, but they pretty much function the same. So just use Nano unless you have a reason not to. All right. Well, let's remove that file. Now, if you're curious what the other things look like, let's look at VI. Yeah, um, does a whole set of things. I barely know how to use it, but you use colon and then various commands. I can't even. Oh yeah, I honestly don't remember. Let's see. Oops. Okay. Oh, that's argument. Okay, so test one. So okay, then quit. All right, so that's VI, and then there's I guess Emacs is not even installed. Weird. All right, so we can tell what they prefer, and then we did clear. Now there may be your terminal program you're using to connect to the system. Some of these commands like clear may do something a little bit different. I'm not entirely sure. Who am I? Oops, there we go. Oh, we know who I am. So we have some other basic useful commands. Now touch, it just creates a file, nothing else. There's nothing in the file. This could be good for setting initial permissions and such. You got locate and you got find. Locate looks for a file based on name, but keep in mind it's actually looking up an index. That index might not be instantly updated the second a file is created. In fact, traditionally it wasn't. I want to say once upon a time, certain maintenance program had to run, and that might be hours. Nowadays, I'm not really sure. Find is similar, but it's even more powerful. You can find all sorts of things based on all sorts of parameters, and you could even probably pipeline it into. I'm going to do a video on all that sort of thing. Zip, unzip, so you can compress, decompress files. Gzip has been more popular with Linux, but yeah, same idea. Now, gzip doesn't, it just compresses a file, but traditionally in Linux, and this is long before, well, okay, in Unix and whatnot, but this is long before zipping files in DOS and Windows was a thing. Um, is you have to combine all the files together into what's known as a tar ball. So tar, untar, put it into a file, and then gzip it to compress it. That's why you'll see a lot of Linux stuff as .tar, .gz. Uh, Chrome or Chmod, people said it different ways. Chmod. Oh no, that's Chmod. Yeah, changes file uh, ownership. Oh yeah. Sorry, this is shown. Changes file ownership. You can just change whoever owns the file. I may require sudo root access, but that may depend on the system. And then history just gives you a history of the commands you've entered. All right, so let's try out some of these commands again. Let's do the clear. Let's try history. Okay, here's a long history of all the commands, and yet it goes up there. Actually, let's do history. Oh, less. See what we get. Uh, yeah, it goes all the way back to command 1369, and then it goes all the way up. So all sorts of. I mean, there are tools on here that I used there's commands on here that I used 3 years ago that are still in the command history here. I'm just going to exit out of that in general. Um, touch, I don't know, touch file one. Let's file one. I don't know, would Bob work? Oh, okay, there's no user. I don't even know what users are on the system other than my account. Can't really show that. Actually, wait a minute. Let me do that and root maybe? No, it's you? No? Okay, super user. I don't know. Whatever. Invalid users. I have no idea who else is on this. All right, let's try locate test file. Oh, I guess we don't have the locate command on here. That is my mistake. Let's do find test file and such. Okay, test one. All right. Not sure it's the extent that that's actually searches. Let's do this now. No, okay. All right, let me do some compression here. There's test file one. Let's zip it. Test file. Oops. Test file one. Nothing to do. Did it actually make the thing? No. All right, let's try that again. Test file one. Zip. We have the arrow pointing to what we want to make. Yeah. Okay, it made it. All right, so let's unzip that. However, to, this okay. Interesting. Let's do one, two, well, two. No, that's not gonna do it either. Oh, wait a minute. I'm not being smart here. Oh, that's gonna work either. All right, let's remove test file one. Now let's do this again. Probably missing something up here. Oh, it's not gonna work either. Weird. You can tell how out of sorts I am. Oh, path of the. Hmm, strange. Oh wait, no, maybe I did do it. Oh no, let me try this again. Move that. What's this in test one? Nothing. Okay, remove that. Okay, now unzip test file one. No, I didn't do it either. Okay. No, it does do something. Oh, okay. It's just gotcha. All right. Test file. Well, let's touch test file one again. Let's do nano. Okay, let's do zip test file. Nothing to do. All right. Okay. You can tell how often I do this. Let's just try the gzip. Okay, see, that's no problem. It puts it in, it gzips it, it takes it away. All right, let's unzip it. Okay, all right, there we go. Let's tar it up, I guess. See. If hmm, tell how long it's been since I've done this. The X is extract. It's great. Oh, refile test tar. Oh, okay. Yeah. All right. So, let's see. Okay, and it's just let's see. Okay, so yeah, it untarred it. Now, there's a thing known as super user, sometimes colloquially known as root. This is basically the single account to rule all other accounts. The next level below that are administrators who may have root access by belonging to the su or sudo group. Now, having access to the root account or even just having root access can be absolutely devastating. It can allow a user to basically do and delete everything. Um, there's stories of people having that access go to the root directory and just hit rm dot slash dot slash dash rf and then just asterisks and just deleting everything. I think since then there are a few security features that may perhaps prohibit you from doing that, but I'm not entirely sure, and I wouldn't bet on it either. Um, now that's also we call it root access because the root directory, and usually being able to alter stuff at the root directory level requires super user access. Now, since accessing the account can be problematic, most people just add administrator accounts to a sudo group, which gives them access to the sudo command. So basically separate su and do, super user do. If they're added to the group and they need to perform a super user function, they simply add sudo in front of that command, like sudo make directory. It may require them to actually re-enter their password or even a special password to proceed. Arduino Uno does. It's a good security feature. Other ones don't. If you actually want to log into the actual account, just put su in there, su. Keep in mind, by default, on a lot of systems, on those distributions, it's intentionally locked out so you can't log in. You actually have to go into the files and allow it. There isn't really many instances where you want to do this. I think the only instance I've ever used it for was when I accidentally deleted all the administrator accounts in the sudo group. I was young. I needed the money, whatever excuse you want. Now, the control key in Linux is really important. Control C forcibly terminates whatever you're currently running in the foreground. Control Z, that usually suspends that process, pushes it into the background, which can then be resumed with the command FG, typing it out. Control D is end a file that may log you out, or it may just close the terminal window altogether. You can also have different virtual text consoles, TTYs, Control plus Alt plus F1, F2, F3, all the way up to 6. That allows you to essentially have multiple console windows open at the same time. If you're in desktop, you can also do Control Alt and the arrow keys. There's definitely going to be a lot of other uses for the control keys in programs, desktops, check documentation. All right, let's look at some of those control codes. Okay, C is not doing anything, so let's just bring up nano, and control C is not doing anything in this case. So we have to control X to X out of that. Let's see what else. Um, Not really sure I'm thinking here. Um, I don't know. Let's just say cat mem info 2 pipeline list. We'll see. Now control C will sometimes do something. In this case, it didn't, so it'd be Q. Um, we can also put things in the background with. It's not going to work for this. Actually, it's a specific key to suspend. Oh yeah, okay, Control T, then Control Z. It suspended it, but it's in the jobs. We can bring it to the foreground with FG. All right, let's see about other sessions. On one, two. Okay, it's not working in this terminal. I think. Nope. Okay. Yeah, this could be the fault of the terminal program itself. Then we have the chmod command, or chmod. however you want to say it. It changes the permissions on a file or directory for read, write, and execute. That's very important. Um, it can be set for you as the owner. It can be set for a group, users in that file's group, um, and other, which is basically everybody else. The classic way of representing this is an octal, which combines the read, write, and execute into a single value from 0 to 7. Now, 777 would give read, write, and execute to everybody. 0 would be no permissions, 1 is execute only, 2 is write only, 3 is write and execute, 4 is read only, 5 is read and execute, 6 is read and write, and 7 is read, write, and execute. If that's a lot to remember, don't worry. They eventually took mercy on us, I think, at some point in the late 90s or early 2000s. So they added symbolic representation U, G, O, R, W, X. So you just combine whatever you need to with a plus sign. So GUO plus RWX does what 777 does, but I still like the numbers, even though I can never memorize them. Um, it can also be used for directory with the dash capital R. It should set permissions to that directory and everything in it. All right, let's see how that works. All right, let's, okay. Now well, you know what? Let's remove that file. Let's touch another. Okay, let chmod 1. Okay, that's not going to tell us anything. I'm trying to remember. Changes silent verbose. I think there's a way to actually wait a minute. Okay, let's look at our test file. You'll actually see the stuff listed here. I'm not mistaken, it is group, user, and then owner listed here. So we've got read and write for the group. Actually, I might got that confused. I can never remember. But let's just change it so that everything, you change. You know what? We'll start with a 777. Okay, and do test file 1. All right. Let's take a look at test file now. Now you'll see everything, all 9. The character in front. Let's see. D. Okay, yeah, that's direct. If it's a D, it's a directory. If it's not, then it's just a file. Now let's change this to, I don't know, 744. Test file 1. Let's look at test file now. So that we've set basically it's read for the others, but it's read, write, and execute. Let's see. 744, I think that would be, yeah, or maybe I can never get it correct. Okay, so when you're looking at it in a directory, it's owner, group, others. All right. So yeah, test file would be owner is read, write, execute. Um, Group is just read only, and others is our 744 is a popular thing. But we can also do let's see, let's do basically everything RWX and then test file 1. See, we can do that as well, and it's changed everything back in this case now. Now, file we can execute is going to be in yellow, I believe. So let's actually change things again. We'll take away execute. Yeah, you see, it changed the color, so nobody can execute the file directly. That's not to say you can't use it as an input to a program. It's not. That's not quite the same thing. So this begs the question, what next? Well, this was just meant to be a very general introduction to Linux. Many commands are exclusive to sudo and root. Others are dependent on distribution, version of that distribution, and installed software. If it's your own system, it's easy enough just to install stuff, but if you're on somebody else's system, you may be more limited, but you can still use a lot of basic things. If they give you an account, they'll probably tell you what you can and cannot do, including space and whatnot. If you're doing this on a development board, there's software libraries for interacting with the GPIO pins, other hardware functions. If you deal with a Pi and actually probably other ones as well, I mean, there's libraries in many different languages. Um, Systems can be configured in so many ways, so it's always possible. Everything from default file permissions to home directories, everything could be non-standard on a given system. There's plenty of systems actually that will actually give you free basic shell access. Some of them have been doing that for 20 plus years. Some university systems, they're not going to give you much access, but they'll at least let you tool around with basic commands, get an idea for the command line. I've seen a lot of ones for Ubuntu, free, open, net, BSD. If you want to check out those, Dragonfly, which I've never used, but I've noticed a number of free account ones for that. Open Solaris. I've used either Open Solaris or Solaris before. Open VMS. This is something that's sort of in the general Unix-like family, but it's kind of a whole other beast. I've never used the open version. CentOS. I've even seen ones that still run Slackware. Plenty of ones that run Debian. I've seen a number of ones for Red Hat, Fedora, Red Hat Enterprise licensing. Because again, Red Hat wants you to buy their commercial product. They're going to let you check a few things out. Just to keep in mind, everything can be extremely limited. If you can get a hold of a spare laptop, desktop, it can be a good couple of years old. Um, that's great. You want to pick up a single board computer, you can still get 3B pluses for, I don't know, maybe 40, $50. But if you can afford a little bit more, get a 4 or 5 or something else and just learn things at your own pace, maybe even take the opportunity to get into the programming as well. Well, until next time, have a good one. So, just to wrap things up, Linux is an operating system, but it actually refers to the core of that operating system, which is known as a kernel. It came out in 1991 as a free alternative to Unix, and it's part of the larger Unix-like family. And Unix goes all the way back to 1969. Linux itself is many different distributions, probably well over 1,000. At least several hundred are still being actively maintained. Some of those distributions can be grouped into families that are based off older ones. Debian Linux and its derivatives, very commonly seen on Raspberry Pis, Arduino Q, Uno Q, and some other systems. You can access Linux through a desktop environment, sort of similar to Windows or Mac OS, or you can go old school with a command line. You can also use the command line through a terminal emulator in the desktop. If you're familiar with DOS, command prompt, PowerShell, you'll see a lot of similarities. If you're not familiar with any of that, you will possibly have a more difficult time learning Linux command line. There's a lot of useful commands to learn. Some of them are going to require super user root access. Although the account itself is usually not available for login, you join basically are put in a super user group that makes you an administrator. You can get you can often get free shell accounts on some other systems, but your access is going to be very limited. Um, you can put some form of Linux on just about any device over the last 20 something years. If you've got an old 10-year-old computer that still runs in your closet, you can turn that into a Linux server pretty easily. Um, Otherwise, single board computers, Raspberry Pi, even an older one like a 3B Plus that you can still find. Keep in mind some commands and settings that can vary from distribution to distribution and system to system. Well, until next time, have a good one.